Time for another coding update. I'm still working on implementing my version, or trying to implement this DFIP that's currently in the voting process. And there was quite some success, great success in the last days. So let's quickly go through it, what happened and where I'm standing. As I said last time, the loan payback is currently on hold, and I wanted to focus more on this creation. And I actually managed to get all the loan tokens and pools created, however, and to rename DUSD and convert all the collateral, loan tokens, and pool reserves. Yeah, next steps will be the locking of the actual balances and stuff, but let's look into it, what I actually did. Okay, maybe make this a bit bigger again, so get the stuff out of the way, then you see a bit more. We can actually just close it. So first thing, it took me some time to realize or get a better understanding on the how this whole token creation on the split works, because usually a token is created with a transaction, so there's a creation transaction and everything, but if you do a split, you don't directly have a token a creation transaction, but they get the transaction. And what's actually happening is that in the miner transaction, and again I got that from the existing code, where they have this section here in the miner, in the create new block. When a miner creates a new block, in this section, if there are splits, either the old ones or the new ones with the fractionals, they add the split DVM transactions, and also above the DF23 also the splits for the EVM transactions. So they add that here, and I kind of brute force added the stuff here now. Actually, I just took the code from in there and reused it here. So I still have to do here to maybe make that nicer, reusable and everything. The main thing is that the existing logic on the token splits is that you have only one split at a time, and it's always happening the token with the pools in combination. So this token and this pool, usually one pool in our case, needs to be converted, right? And for us now, if I do all loan tokens at once, this doesn't work. Or I mean, it could work, but then you split every token, every pool twice, because we convert a DUSD to USDD and every dToken to a new version of the dToken with a split modifier, a multiplier of 1. And if I do that now, I just reuse the existing function and do it for every token one after the other, then I split the SPY to the new SPY, split the SPY DUSD pool to the new pool. Then when I come to the DUSD, and I do that for all loan tokens, and when I come to the DUSD, I split the DUSD to USDD, multiply 1, so split, it's the wrong word, but I convert that. And then all the pools where DUSD was in, so every pool that I just converted to a new one, I convert again. And I think that's just a waste of IDs and a waste of resources and speed. So not doing that, but have it a bit differently. And that's why I'm using this separate stuff, because here the original one is that it creates this loan split, this split transaction, which is a coinbase transaction. So no input, just a transaction in the done by them, created by the miner basically, and it has the ID or the type, and in the original one the type is 0, means it's a token creation transaction, and the other types are the pool creation transaction for the ID or the ID of the token. And I thought about that, how to best change that or use that we can do the pools and everything, because now I can't connect the pool to a token, and I can't just say because it is like that now that it should be in the code like that, because the code is for generic chain, right? So I'm like, okay, we want to convert all loan tokens, and I want to convert, so I don't say I connect the pools to a token for the conversion, but I convert all pools and tokens that are connected to the loan tokens, and I have just all of them. And therefore I will create a transaction with ID 0. So all just the type is just that I have the same structure, type, ID, and multiplier. But the ID is the ID of the pool or the token. So because the pool also has an ID, because it's the token ID of the pool, basically, the LP token ID. So I convert that, and the multiplier is always a coin, so always 1 in our case. Create token lock split transaction. And that's just a function here, so kind of a lambda that now we use, because for convenience, and since I have it in multiple places, that I need to go do something for all the loan tokens and the pools connected to the loan tokens. And I don't want to have the pools multiple times, just once and stuff like that. So I made one method, and maybe look at that right away, because I also used that here. Exactly. Where I created one method in the same style as this for each loan token and stuff that we have, where I say, okay, I have this function and I get callbacks for every token and every pool that I call, and I just go through all the loan tokens that I have, because I have this give me all the loan tokens for the lock, which just gets the loan tokens on the one hand. That's another thing that I found out. First I thought this for each loan token goes over all loan tokens, and that's what I need, right? But the thing is, previously loan tokens were stored like that, but it seems like after some hard fork, they are no longer stored like that. So now they are all done in the attributes, so that the attributes define what tokens are loan tokens. So this for each loan token actually gives me nothing now. I kept it in here because in the future swaps and everything, it's still done the same. And I'm not 100% sure. Yes, likely the token locks are just done after this fork, and therefore you can assume that it's always, this will not be relevant anymore. But for now I kept it in, because cleaning up is after I got the structure and everything and the logic done. And therefore I have this method that says, okay, this gives me a collection of all the tokens connected for needed for this lock that we then have. And here we go through the attributes where loan minting is enabled. Then I convert it out. And yeah, so I get all the loan tokens and then iterate over all the loan tokens. And on the one hand, for each loan token, I do the token callback. And then I go through all pool pairs and check, on the one hand, did I already report that pair pool? If yes, just ignore it. And if not, I check if this current loan token is in this pool. If yes, I, on the one hand, add it to the reported pools, or checked and reported pools, and then see was it already destructed or not. If it's destructed and not active, I don't report it, but I add it still to the list of already processed pools, because yeah, I don't need to check again, and yeah, do the callback if the pool is relevant for us. And therefore, if you do that, you go through all the pools and loan tokens that are relevant for this token split. And that's this, no need to have it token to pool, no connection to that, but just get all the tokens and all the pools that are necessary for the lock and do something with them. And therefore I have here now this small lambda, and then call that here with saying, okay, with the ID, on the one hand ID of the token, and on the other hand ID of the pool, which is the ID of the pool token, of the LP token. And it's just the if it's a pool and a token or not, because if it's a token, then I add this transaction, this creation transaction that I added here, not only to the chain, but also to the list of split transactions for EVM, because afterwards I also now have it natively, and for the tokens itself, they also need a transaction on the EVM because they are also split or converted on the EVM. And it's also something that I did for most of these methods, that I added this token suffix parameter, because previously it was hard-coded V, so for V1 and stuff for old tokens. But I thought now for this lock, let's not name it V, then V3, for example, if this token was already split before, but name this one lock1, so to have it in the minute, because then also when we go through the descendants, we can see is this descendant a lock, or so is it locked and they have to do the lock logic, or is it a normal token split? Exactly, and that's beside that, it's the normal method from already before, where they already split the token for the normal splits or create these transactions. So with that, the miner adds the transactions to the pool, to the block, so that the coinbase transactions are in the block. And now we need, on the other hand, here in the process token lock, I go in, nothing changed in the forced closed loans, but I go through in my current block, because this is done in the connect block when I add the block to my, or process the block, right? So on this block, when I said, okay, let's process that, we assume that there are those coinbase transactions in, because the miner created the creation transactions. And we go through the block and check if this is a token split marker in this block, so in this transaction. And if this is a token split marker transaction, then we get the ID out of it, multiply as a coin. So if this is all fine, we save this transaction per ID, that we say that's our creation transactions, and get the hash so that we can use the creation transactions now in the further process. And this is now per ID. So for the pool and the tokens, that's the same. And then, so we now have the creation transaction per ID in our map up here. And then we create what we need to use the existing token split functions. So I just, again, go over each lock and token pool for the tokens. If I don't have a creation transaction for this ID, yeah, I can't split it. If I can, I add the split to say, okay, this token ID split with multiplier 1, so it's split, but yeah, not just to get a new ID, and reuse the existing function of changing all the balances, changing loans and stuff like that, and also the collateral, and also add the creation transactions there. And one important thing, as I said before, or in the normal execute token splits, they expect to have an ID of the token plus the creation ID of the token and a list of pool pairs that should be split, and the creation transaction for the new pool pairs that's converting from there. But as I said, this pool and then a token and a list of pools doesn't work in our case. So I changed that a bit, that I now provide them a list of the tokens plus empty pool pairs for each token. So to say, just split the tokens, no pools to split, nothing to be done there. So I can use that, and then I do the pools myself. Exactly, and for the pools, if for each pool I also get the transaction and save it for me in the creation transaction per pool ID with the ID and the creation transactions. Exactly, and one thing, because this method to split the token requires the token to be locked. So I set the lock and attributes right before the lock, before it's happening. Just to make sure that it's not needed to be set manually, but not sure if this is the best behavior. But yeah, so it works. It's just for now that it works, and then we can refactor it once the whole logic is ironed out and everything works as expected. Exactly. So now everything is prepared. We have the creation transactions and everything. And now I execute the token split itself, and this is the standard function I just added. On the one hand, I added the this suffix, and yeah, that's all I added here. It's just a suffix. The other things, the splits and creation transaction map is the same as before, and it goes in. This does a lot of refunds futures contracts, so we already have that done now. So this is handled, and does all the stuff that's all standard. The only thing that I want to show you is a bit down here. Also the ascendant and descendant keys come in, so everything is handled. The only thing is this pool splits, and before this was just called, and if it fails, there's a continue. And now I just say, okay, if the creation transactions is there, I mean, I can likely cancel, remove that, because that's always true, otherwise it wouldn't even work. And the pool pairs, so the part in the creation transactions there are pool pairs, then do this, because in there I also had to change a bit in there, but that's in a second. So this is only called if there is a pool that I want to split, because otherwise it says I can't split an empty pool and just continues, and then it converts the balances and everything as before. A few words to that. Previously, the pool splits was done for with the parameters old token and new token. But yeah, I want to reuse this pool splits method to have a list of tokens that are split, and with a map of this token to this token, this token to this token, and so on. And therefore, I changed that it's no longer one attribute of or two parameters, old token, new token, but a map of old token ID to new token ID. And then the other thing is the same. Here you have this assert that it should handle, so it must only be called with a list of transactions, a list of pools that needs to be done. That would have made problems if you don't do the check outside. And then in here, there are a few changes wherever we have the handling of the old token ID. I mean, there you have the suffix count and see if what you need to do in the renaming and everything, so all clear. And that, for example, previously we had this: if old token A ID, token A is the old ID, then do that. So we replace that with the new ID. Otherwise, do it for token B. And now it's like that I say, okay, if my token A is in the map and I need, then my new token A is the new value from the token map, the new ID, and the same if the token B is in the map. So there's no if else, because it could be that both tokens are changed and converted to a new one. But all the other logic is all there. So it's get the token for the new ID. And this is also important. That wasn't here before, because before there was no renaming on a split. And now I'm like, okay, ensure that the symbol is correct, because outside I change for the DUSD to USDD. So I allow for the name of the token, of the new token, to be different. And I say, okay, token A, token B for the new pool token symbol, and created a pool token, and we have the new pool ID of this pool token and everything. And yeah, that's basically what's happening, because everything else is the standard, the reward consolidation because of the pool changes, and the migration of the balances to move it from the old pool to the new pool. So there is no locking or anything. This is all just the first create the new tokens, convert all the balances, everything to the new tokens and new pools, and then we start the locking. Exactly, and that's what's happening here with the reserves and everything. So actually nothing happening here, nothing big, just this change that these pool splits now work with a map of tokens, also can split multiple pools with multiple token changes at once. And so in here, now we do that. We first execute the token splits without any pool splits, and then I just take the new DUSD token because it's now already split. So this is now the split one-to-one token of DUSD to DUSD. So new ID, I get this new token, and I rename that to USDD and update the token. And if that all worked, I don't have to do anything else because now this is still a loan token, just a different name now. And now the one thing, maybe think about that to do, should we rename the oracle so that it's, because now it's DUSD, USDD, so we renamed it to USDD, DUSD, USDD, USD. Likely this should also be this new oracle. So it has a new oracle and everything's there. But to do for later. And then when I have this the tokens converted, token renamed, I get from the attributes the descendants, where I say, okay, what's the for all my tokens that I have in the splits, so the old tokens, what's the new token? What was the token that I got out of it? And put that into the map. So I have the map of old token ID to new token ID, and then use the spool splits with this old token to new token map, and again use the lock as a suffix, and split the tokens, split the pools. And with that, we nearly have all the changes. There's just one small thing that I forgot to show you. It's in here. We have the volt splits, because somewhere down the line, it's a long function. Yeah, here we have the volt splits. So doing the token split, the volts are also converted. And there it's important to now only the loan tokens, so the loan amounts were split. Collaterals, there was no, so DUSD would not be able to split right now in the live code because the collaterals are not changed. And I just took the handling of the loan token amounts and changed it to void collateral, also to add also the handling of the collaterals, that I subtract the old collateral, the old token ID on the collateral, and then afterwards, I mean, they do the whole interest calculation, doesn't matter for collaterals. And at the end, I go again over the token amounts, and it uses the same logic. So assume that there's an identifier. So I just improved this already the method to say also use check collaterals if this token split affects a collateral token, and adds the collateral. One thing that I'm not 100% sure is this volt history writer, because this is it writes the history, a history entry for changing the balance in the vault, so for changing something in the vault. But there is no the token split. It seems like this token split is just for loan tokens, so there is nothing here that I can change to make it be a collateral change. And I guess it assumes that the token split is always a loan token split, and therefore this custom token split makes or is implicit that the loans changed, but it also can change the collateral. So there's maybe it also fix me make this clear to be a collateral change. So that's something that that you need to look at, because the same happens here, and it's just that nothing in this somehow indicates that this is a token collateral or a loan. Exactly. but that's the stuff that's happening there. So that's the volt splits, and we are now basically done on our side. Where are we? There, in the token splits, and that's basically everything that happened here, the pool splits. And only one thing, and that's something that I need. First, I thought it's because of these creation transactions. Maybe it is. But when I mint this block, when I do this and mint this fork block, it fails because the EVM block hash is invalid or incorrect. It's not matching with on the connect. So the block is created, everything is fine. But when the node tries to connect the block that it just created, there is a block hash mismatch in the EVM side. And I don't know why. I know this happened, and there were some errors when developing the DMC, that something in the pipe of the creation and the connection of the block was handled differently. I guess it's something to do with my creation transactions, how I create them. Not 100% sure why, but for now, I just added the ignore. I ignored this error out so that I can check the logic on the DVM side, and later, I need to check what's wrong there, because even now I create these Coinbase transactions and everything, it's still mismatching. So yeah, that's the topic. Yes, so that's basically what happened. And if we look at the changes, on the one hand, so this is the test that's still failing because it's not everything is done yet. But as you see, it fails here on the number of that. I already changed that to USDD, but the locking away is, of course, not done. But what's already working, and this you see here, okay, I have the print, but that doesn't matter. So reminder, this is where we have the fork block, and then afterwards the locks need to, all the tokens need to be split. And afterwards, if we get all the tokens, we have DFI, not a loan token. We have SPY and DUSD now with the lock1 suffix and no longer loan token and not mintable. Also the old pools are, never been mintable or something, but pool tokens are with the lock suffix, and the new tokens, SPY is created, USDD is created, so DUSD converted to USDD, and we have the new pool tokens SPY, USDD, and USDD DFI. And even when we get the pool pairs, we have the old lock1 pools, and we have the new pool pairs USDD and USDD DFI. I didn't check the reserves here, so we can also make it to do. This is now Python. Check that. Check. I can check it directly. I think I have it also down. Yeah, down here. But we'll take some time until we are there. And yeah, that's so. Those two are already correctly working. They are fine. I didn't check the balances yet. I mean, I print them, so I think I didn't check honestly. But yeah, we'll check after the volts are fine. Or maybe we can just move this this check up, but it would also be wrong right now because it's not the locking is not in yet. But one important thing, if you look at the distance, the difference, so yeah, the assertion is wrong, but in the vault we have 150 USDD, which is exactly what we want. No longer DUSD, but 150 USDD. So this conversion of the collateral also worked. Collateral amounts are converted now in a token split. So all that worked, kind of, except for the EVM stuff. Also, I quickly ran all the tests, and some of the old tests are failing now. So something of what I changed there there's a topic, so I need to check what's topic there, why is it breaking. But yeah, that's likely just with all the changes in the parameters, I missed something somewhere, some check or something, that the old code is still working. That's why you have tests to see if some changes break old code. And I didn't review anything yet. It's just that I tried to get a handle on the situation, on the code, on the, yeah, how to move in there and what to change where. What a bit of a struggle with these creation transactions, but I think I have a bit of an understanding now. So this is working. First step done, basically. And now the next step, as I said, converting or locking all the balances from the collateral, from the pools, and from the balances away to, yeah, have the lock, and then we can also start checking the lock balances and the lock ratio. So with that, thanks for watching, and if you have any comments, feel free to leave a comment. Otherwise, next update, next progress. See ya.